Alright guys, welcome to LeetCode weekly contest 241. I've got it open for you. And yeah, yesterday it was not an easy day for us. We had several wrong submissions. Let's hope that today we can get all 4 problems done without any wrong submissions, and also a bit quicker than previous time. It will start in 20 seconds or so, and yeah, it's again quite early here in Ukraine, but I believe I don't know, if you want, we'll enjoy some street views a bit later today, after the contest, I mean. Because it is beautiful, but now it's time for a contest. Okay. Problem A, sum of all subset XOR totals. The XOR total of an array is defined as a bitwise XOR of all its elements, or 0 if the array is empty. For example, XOR total of the array 256 is okay. Unary nums returns the sum of all XOR totals for every subset of nums. But that's strange. Oh, you want to sum all the XOR totals. And what is length? Length is up to 12, so we can just brute force this. So there is no point in doing anything else. And what we are going to do is clearly we want loop over all possible subsets, which is usually done with looping over all bit masks. So we'll create a variable answer, we'll go here, we'll say like XOR equals 0 for bit in range n if let's say for bit num in enumerate nums, actually, if a mask has this bit turned on, then XOR gets XORed with num, and here answer gets incremented by XOR. Let's check versus samples. We should get 6, 28, and 408. That's exactly what we get, so let's submit. Got accepted. Problem B, minimum number of swaps to make the binary string alternating. Given a binary string, returns the minimum number of character swaps to make it alternating, or negative one if it's impossible. The string is called alternating if not two adjacent characters are equal. For example, the strings... Oh, you meant adjacent swaps or which swaps? Not necessarily adjacent, so you just have like this. I don't know what we should do. I really don't know. Wait, that's simple, right? So we only have 2 or so alternating strings. And then we want to find the number of character swaps, which I believe is like number of positions that differ, and then +1, and then round and down. Or number, yeah, something like that. So, so we'll have to, like, A counts the number of swaps necessary if you want to start with 0, 1, and B counts the number of swaps necessary, or I should say different characters, if you want to get 1, 0, 1, 0, 1, 0. I don't actually think that we need this. No, we do. If I is odd, then for A we expect E1, I think. If character is not equal, let's say just 0, then it actually doesn't matter which one we increment. Okay. Now here I believe the answer is like this, because if you have two characters that are not okay, then you will need one swap to change them. But we also want to check that yeah, let's say A0, B0, A1, B1, A0, B0, here B1. Wait, but then they are counting the same thing, so I really should do it like this. Yeah, no, the idea is that we don't necessarily have an ability to swap to 1, 0, 1, 0, because we may have a problem that we just have a different number of these guys. Right? Different number of characters to what we need. Let's also grab the length of the string. Now, if length is odd, do something else, we'll do something. That's getting a bit long, but that's fine. Don't worry about that. It's more important not like to get the logic right without any wrong submissions. So don't worry much about that. I think we initialize with something like really big. Let's say our initial answer is n, n plus 1, I don't know. If m still equals n plus 1, we will return -1. We'll return n here. A0. A0. Wait, should I actually do it like this? I thought that I should increment A1 here, actually. Oh, that's no. I just did something not good. Let's stick to the original plan. If n is odd, let's also have AB is equal to s count A or 1 s count 0. Now here we want in both cases k is equal to n over half. If k is equal to a and k plus 1 is equal to b, it means that we should be able to swap that means that we can get a is a count of 1, so we can get this. If k plus 1 is equal to a and k is equal to b, it means that we can get this. We'll have to update answer accordingly. And here, if k equals a and k equals b, and we can get both and this and this. If we can get 0, 1, 0, it means, like, what does this count? Oh, I believe I have to increment actually like this. Yeah. So it's... No, wait, so it's like this. Okay, so here we count once in even positions. Here we count zeros in odd positions, and we basically counting what is wrong with the string. So it means that actually when we try like this, then we aiming to get 0, 1, 0, 1, 0, 1. So A is aiming for 0, 1, 0, 1, 0, 1. I'm gonna do it like this. So it doesn't care about length for now. It means that we should use it here to update. M equals minimum of M and A plus 1 over 2. Here we can use both to update. Yeah, I definitely overcomplicated it a lot, but sorry, it's early in the morning, I don't exactly know. Okay, that doesn't sound good. Because for this string, we should get in both here and here, no? I don't understand. Wait, we print nothing? What? Oh, because I used small b here. Now we're getting the correct answers. I really don't trust myself. So I will create some more tests. I don't know, can we have an empty string? No, we can't. Okay. Definitely strings of length 1 should be considered. Also, let's ask what it thinks about this. Will it output 2? It outputs 2 strings of length 1 already. Okay. Yeah, we got accepted. Spend a little bit of time here, but the main part was not to get wrong submissions. Problem C. Finding pairs with a certain sum. We are given two integer arrays. We are asked to implement a data structure that supports squares of two types. Add a positive integer to an element of a given index in the array nums. 2. Count the number of pairs ij such that nums I plus nums j equals a given value. Okay. What are the constraints? The values of nums2 are quite small. Are we guaranteed that it will remain small? Also, length of nums1 is quite small. At most, 1000 calls will be made to add and count each. 1000 calls to add and short nums1. To be honest, I'm thinking that we can do something quite cheap here. Like what is total? Oh, it's a parameter for counting. Okay. But that's like stupid, no? Let me explain what's in it. Like, we want to add value here, right? And this is not good. So what we'll do, and then nums2 will get a dictionary for num, and we'll just bash everything into it. I assume we can do it. No, we should. Yeah, whatever. Like, we should actually copy it because we'll need to adapt it accordingly, but what we can do now is we say like, okay, self map at num gets incremented by 1. Default default dict of integers. Why? Because now we can say like, okay, self map at, and we take this value, it gets decreased by 1, then this value, updated value, gets increased by 1, so we are effectively storing frequencies of numbers. And because we don't have many calls to add and the nums length is short, we can just loop over first nums and let's say like answer plus equals self map at total minus num. Because I don't really know what else we can do here, to be honest with you. Like, in sense, reasonable. Oh no, total is not defined because the variable name is tot. Whatever. So we got null 8213. 82111 actually. The last count should return. Oh, because we decrement in here and we should increment. Copy pasting is never good. So 82111. Yeah, I don't really know what else we can do here, to be honest with you. Oh, we got accepted, so number of ways to rearrange sticks with case sticks visible. There are n uniquely sized sticks whose lengths are integers from 1 to n. You want to arrange sticks such that exactly case sticks are visible from the left. Stick is... Wait, I remember that problem from binary search. This time I'm not doing these mistakes. I will just go there and find my solution. Because I do remember that problem. It was with I bet we won't find anything. Visible blocks, I think. You're given two integers n and k. There are n blocks with heights ranging from 1 to n. Returns the number of ways in which these blocks can be arranged in such a way that if you look from the left, exactly k blocks are visible. Stupid. What can I say? That doesn't look right for some reason. No, that's a complexity that you want, I assume. Yeah, you're absolutely right. Both of them are up to 1000, so here we're doing effectively two-dimensional IP, but we just bashed it into one string because why not? Right, I think it's completely reasonable. We can, oh, we wanted to mod it out. Okay, no big deal. I will just separate it like this. If n is greater than 1, we want to return this value modded. Mod, just 10 to the 9th plus 7, I don't know. Otherwise we want to return, no, like if k is equal to 1, turn 1, also turn 0. 647,427,950. I think it's fine. Let's just submit it. I hope it doesn't TLE. No, come on. No, really? Oh, so stupid. Like, it's really sounds like it's about Python, to be honest with you, because that's just so stupid. Like, how can a quadratic DP TLE for 1000? so disappointing, honestly. I assume it will need here and here. No, but no. And also it should be long, I think. Come on, that's just bad of them. I used cache. Is it imported by default? I hope it is, because otherwise it's like stupidest mistakes. So for j from 0 to n, or x actually should be I, right? No, that should be j, and it should range up to k. I want to initialize. How should I initialize? Oh, I actually don't care. I just have to initialize 0, 0. It should get 1, and then and then I just write my DP. So. We have a bit uncomfortable change of indices here, but that's okay. dp at ij should get what? dp at I minus 1 j minus 1 plus I minus 1. No, actually plus I, because remember we already subtracted 1 from indices times dp at I minus 1j, I think. I think something strange just happened here, because what if k gets to negative values and we say like doesn't matter because we will. Okay, that was a strange solution. I don't remember how exactly it happened, so that negative values don't matter. Okay, so what should we do here? That's relatively short. I think it's like this, actually. No, I did something wrong. What did I do wrong? So I shifted indices once, and it means that for n is greater than 1, so n equal to 1, it's here, and it gets to first index equal to 0. So I say like if k is also equal to 0, then it's 1, otherwise it's 0, it's initialized by all zeros here. And then I say, to get this current value, you take this value. Oh, sorry. Take this value, which corresponds completely to this indices, and you take n minus 1, which is I, and multiply it by n minus 1 k. So j does not change here. Oh, do I have to take care of negative k's as well? Oh. But I don't want to take care of negative values of k. That's just so stupid, like we already solved the problem ideologically. Why do I have to struggle because of you? Okay, if n is greater than 1, then we want to return rearrange sticks of n minus 1, k minus 1 plus 1 times rearrange sticks of n minus 1k, and then mod it. Else, if k is equal to 1. No, actually want to return cache at cache resize n plus 1 probably. Cache n at k gets this, and then we return it, so sounds reasonable. Here want to return 1, also want to return 0. We can actually put it into cache, although I believe it will make no real difference. That's actually a very necessary struggle here. Cannot be represented as type int, probably because we want to take it like this. Excuse me. Wait, what? Where? That should not be. Okay, whatever. Damn, what we are doing wrong? We are doing something wrong. Oh, and I also did not implement this cache actually. Oh, because we are... Damn, what? This should happen over here. And it's a return solve of mk. And solve is the one who is cached. That says if cache at n count k, return cache at nk. Else. Bro. And still getting an answer. Because this should be solved, I assume. No. Wait, was it n minus 1 actually? Yeah, it was n minus 1. Whatever, let's submit. I hope it doesn't see. What? What? What the fuck, bro? Like, we are doing quadratic DP. How can it TLE? What test cases did you put in here? What? I just don't understand. Am I stupid or are they stupid? What's going on? Why would you TLE quadratic DP? That's not what you want. Like, it finishes not the quickest of all times, but still. And also this method, it caches like all calls. Oh, bro. At least equal. Oh, there should be negative 1. I don't really understand. Like, it should. That's fine. I don't understand. Okay, I added this improvement which doesn't shrink cache. It only like increases cache. so it should be faster. Honestly, I don't understand what I'm doing wrong with my life. That's quadratic DP, how it cannot pass? Who tuned these time limits? What the? Honestly. Okay, we have another trick. We have another trick in our pocket. We have another trick in our pockets. K is smaller than 0, then it will never become big. Am I right? I just don't, apparently I don't understand something in this slide because, yeah. Oh, I'm just angry by now, like, clearly they did not think at all while preparing this problem because they just copied from binarysource.com, and now I have to struggle because of them. That's a terrible way to start my morning. That's our. Okay, so it puts values into here. And we can actually do it in next solution. And here we will just return cache. That's okay. Now our idea here is that we want to know like how to stop. And for that purpose, I'm gonna ask them about the following. Like, actually, it should be ij. I think also up to equal. I here, j here, and then just initial values should be correct. So what are the initial values? If n is equal to 1, so our recurrence works from n equal to 2. I'm gonna say cache of 1, cache resize 1001, I believe. And also we'll just have vectors, because why would we have anything else? And also vectors of shorts, because we will cast two longs here to save a bit of memory. Cache at 1 j should get, wait, that's 0 actually, initially. It's just, I just feel so stupid when doing this, because like idea is really simple. You just have a recurrence. But for some reason they didn't care about our recurrence, and they want to do want us to do something stupid. Count 1 and j equals 0, and the only cache 1 equals 1, I believe. And then we compute all the cache, then here we just return the cache. Huh? Sounds like we ran out of boundaries of the array somewhere, but where? Where would we do that? Oh, j starts from 0, j probably should start from 1. Cache at anything 0 can be 0 because we will never get to 1s, not anymore. So it's 3, 1 and something, something. It also works faster now on samples, so let's just submit. Stupid problem really, like the recurrence relation is really simple. But for some reason we had to do it like this. I don't really know. Oh, so terrible, so terrible. We must be like, I don't know, not in top 100. Yeah, people just... Yeah, we were just terrible because we had 3 bugs. That's... People, I don't understand, like, what did we do wrong? Honestly. We did a quadratic DP, cached it. That should be it in Python. Why am I having any sort of issues with that problem? We should have finished by, like, I don't know, 17 minutes. And that's it. Oh, so angry. Honestly, that's just stupid time limits in Python. Actually, in C++, I don't understand how it can TLE. Yes, in order that map is slow, yes, we should have used vector, but that's not the difference it should be between accepted and TLE. Like, what the hell, bro? I actually heard a lot of thoughts from people like, saying that legit write an explicit DP may be bad on interviews because you can really easily get confused with indices and stuff because like I heard that people say that interviewers actually like when you just cache everything and say like our main objective in this problem was to derive a recurrence and we did it. That's it. Like we don't want to think about anything else. I honestly don't understand. It's just stupid what we had here. Honestly. Also, our boys really good in first 3 problems, actually much faster than me because I spend a lot of time here. But now struggling to get Q4. I don't know, it just feels so stupid. I can't explain my emotions here. Why would it TLE? It's quadratic, like, honestly. I know that LeetCode contests get tested by, like, not that stupid people, let's put it this way. Like, at least candidate master and code forces, or usually, like, master. Do you, like, why nobody came up with Python cached solution? And if they did, like, why then time limit is such that it TLEs? Like, that's the same. That is literally the same. Like, asymptotically, there is no difference between all 4 solutions that we submitted. I don't really know. It's like just... honestly. Like, whenever, like, if anyone asked me to test their contest, I would usually start with something really lazy. And if it solution, like, has a reasonable complexity but TLEs, and I would say, talk to them like, this is actually the same solution, but for some reason with your time limited TLEs, like maybe you should consider being smarter about it and not being like, oh, we know everything in the world. Like we know for sure that the best time limit for this problem is such. Because our solution works as such, and we don't want to look at your solution and your running time. It's just completely unreasonable behavior. Yeah, I assume that the boy. No, this. Okay, whatever. Yeah, like the reasonable time for us to finish this contest was here. No, like probably here. I just don't understand how it could prepare their contest if they have like such time limits. If you wanted to TLE something quadratic, then like there's no like wait, like what am I talking about? Our solution is quadratic and it's fine. It should be fine. Like 1000 times 1000. What else could you want to TLE? N cubed? Well, you don't need that strict time limit for n cubed solutions. Because I believe what we did is not what real people are expected to do. And because we cached all answers, we pre-computed all answers and then just answered from cache. That's not the common technique. Not for interviews. Let's be real. I don't know what LeetCode expected here. I just find this problem. This time, no, problem is okay. Like I liked it when it was solved at first time in binarysearch.com because, like, this there it was reasonable. You just write quadratic DP, cache it, and that's it. Here, that's completely unreasonable. I don't. Honestly. That's just so stupid. Whatever, better luck next time. I guess that's how it goes. Yeah. Really. Bye for today. Have a great day. I hope you like that contest. If you want to see the explanation of Q4, I believe you just should start using binarysearch.com because that's a great platform with really nice people. That is something different about it and LeetCode. It's the people who use it. Because maybe LeetCode has more questions, but LeetCode is all like, profit-oriented these times, and binarysearch.com is just a community of people, just like you and me, who more or less like you and me, who just prepare for interviews together and learn algorithms. Really a lot of cool people there, just join and enjoy. Well, that's all I can tell you. Definitely better than LeetCode Premium, and also free. That's the main thing about it. Okay, bye bye guys. See you next.